This video is a chemistry example of algebraic differentiation. The example we'll be looking at is from the free electron model in a 3D box. All the terms used in this video are numerical values and constants, and they're all defined in the link below. The equation we're starting with is this one, which is n. And we need to prove that rho e equals dn by de, where dn by de is n differentiated with respect to e. This is the equation for rho e. The first thing we need to do is get the equation into form we can differentiate. As in our video algebraic differentiation, we want our equation to be in the form y equals ax to the power of n. As we're differentiating n with respect to e, n is our y and e is our x value. So the first thing we need to do is separate the 2m from the e. To do this, simply remember that the power on a bracket applies to everything in the power, and then just separate them, giving this. Now we need to times the 2m to the power of 3 over 2 by our fraction, giving us this equation. So let's start differentiating. We'll start by looking at the different parts of the equation in relation to the equation y equals ax to the power of n. So as I said before, n is the y, the fraction is a, e is the x, and the power 3 over 2 is this n. As in the video algebraic differentiation, y equals ax to the n differentiates to become dy by dx equals n ax to the n minus 1. So you need to bring this n to the front of the equation and minus 1 from the power, giving us this. Where we have n, a, x, and that's the power of n minus 1. Now to do some tidying up. So these 3's will cancel, leaving the 2 on the bottom of the fraction. And anything to the power of a half is just a square root, which means that once we've times the 2, we end up with this. And as you can see, we've successfully proven that rho e equals dn by de because our differentiating of this equation has given us the same equation as rho e.